Millman's theorem. The statement of Millman's theorem. The Millman's theorem states that when a number of voltage sources, that is V1, V2, V3, etc., V1, Vn, are connected in parallel, having the internal resistance R1, R2, R3, etc., Rn respectively, the arrangement can replace by a single voltage source V in series with an equivalent series resistance R. In other words, it determines the voltage across the parallel branches of the circuit which have more than one voltage sources, that is reduces the complexity of the electrical circuit. This theorem is given by Jacob Millman, that's why it is called as a Millman's theorem. The utility of Millman's theorem is that the number of parallel voltage sources can be reduced to one equivalent source. It is applicable only to solve the parallel branch with one resistance connected to one voltage source or current source. It is also used in solving network having an unbalanced bridge circuit. This is the circuit diagram. Here the number of voltage sources like a V1, V2, V3, etc., Vn with internal resistance R1, R2, R3, etc., Rn are connected in parallel with a load resistance RL. This can be replaced by a single voltage source V in series with the resistance R, and load resistance will be connected across the load terminals. Where V is given by V1 G1 plus V2 G2 plus V3 G3 etc. up to Vn Gn. Suppose if it is 3 voltage sources and 3 resistance are connected in parallel, that can be replaced by the voltage source V is equal to V1 G1 plus V2 G2 plus V3 G3, and resistance is given by R is equal to 1 by G, that is equal to 1 by G1 plus G2 etc. up to Gn, where is G is given by G1 is 1 by R1, G2 is equal to 1 by R2, and G3 is equal to 1 by R3. Similarly, if n number of voltage sources and resistances are connected in parallel, that can be replaced by a voltage source V is equal to V1 G1 plus V2 G2 plus V3 G3 etc. Vn Gn divided by G1 plus G2 plus G3, where G1 is nothing but 1 by R1, G2 is equal to 1 by R2 etc. And the resistance is given by 1 by G is equal to 1 by G1 plus G2 plus etc. up to Gn, where G1 is equal to 1 by R and G2 is equal to 1 by R2 and Gn is equal to 1 by Rn. So here, assuming a DC network of numerous parallel voltage sources with internal resistance supplying power to a load resistance RL as shown in the figure below. So here the V1 G1 is nothing but V1 by R1, and V2 G2 is nothing but I2, and then Z2 and IN Gn. This can be converted into voltage source, or we can represent in the current source. Here let I will be represents the resultant current of the parallel current sources, while G is the equivalent conductance as shown in the figure below. So here I is equal to I1 plus I2 plus I3, and G is equal to G1 plus G2 plus G3. Next, the resulting current source is converted to an equivalent voltage source as shown in the figure below. That means you can convert the current source into equivalent to voltage source. Then as we know that V is equal to I by G and R is equal to 1 by G. Therefore, V is equal to 1 by G, that is equal to I1 plus I2 plus I3 etc. IN divided by G1 plus G2 plus GN. As we know that I is equal to V by R, and we can also write R is equal to 1 by G as Z is equal to I by R, so that the above equations can be written as V is equal to V1 by R1 plus V2 by R2 plus V3 by R3 etc. plus Vn by Rn divided by 1 by R1 plus 1 by R2 plus 1 by R3 etc. plus 1 by Rn. So here R is the equivalent resistance connected to the equivalent voltage sources in series. So in general, this can be written as V is equal to V1 G1 plus V2 G2 plus V3 G3 etc. up to Vn Gn divided by G1 plus G2 plus Gl. Or so you can write it as V is equal to sigma K is equal to 1 to the power of 1n Vk Gk divided by sigma K is equal to 1 to n Gk, and Gk is given by 1 by Rk. What are the steps to follow this Millman theorem? These are the following steps to solve the problem by using the Millman's theorem. The first one is obtain the conductance G1, G2, G3 of each voltage source V1, V2, V3, etc. Find the value of equivalent conductance G by removing the load resistance or load impedance from the network. Now apply the Millman's theorem to find the equivalent voltage source V by the equation shown below. That is V is equal to V1 G1 plus V2 G2 plus V3 G3 etc. up to Vn Gn divided by G1 plus G2 etc. up to Gn. Then determine the equivalent series resistance with the equivalent voltage sources by the equation R is equal to 1 by G. The last step is find the current IL flowing in the circuit across the load resistance RL by the equation IL is equal to V by R plus RL. Thank you.